User-defined functions, data science R Studio. Part 3, advanced R functions. Last time we covered part 1, part 2, part 3. Today we are finishing with part 4, the advanced conditional or logical R functions, and user-defined in particular. So we already have advanced built-in functions in R, but we want to work on advanced user-defined functions. Let me load the database library that's in line 8. This library is very useful for data visualization functions because it already contains 9 key libraries inside itself. The ggplot2, dpplier, tidyr, readr, table, stringr, focus, pool, and labridate. So the ggplot2 for plots, dpplier for data manipulation, graphics manipulation, tidyr, that's for data frame manipulation, the tidy data manipulation, readr for reading rectangular data sets and tables, data frames, table again, that's the imaged data frames, string R, that's working with strings, focus, that's working with categories, that is for categorical variables, pool, that is for logical advanced programming functions and vectors, and then labridate, that's for date and time functions. Alright, but in this course, in this tutorial, we're just interested in the dpplier. Okay, so here you could as well load library dpplier only, but it's fine. If you have database, load database. If you don't have database, just load dpplier. It will be enough for today. Okay. Now, if we run from 12 up to 18, somewhere there. Okay. Let me run, or let me just select up to this one. I'm just setting the working directory, and it should say that the working directory, I'm in this YouTube channel. Okay. Then advanced conditional logic functions. So we work with the conditions and logics. Okay, functions. Example. Let us start with the example 1. Nested if-else for multiple conditions. Okay. So this one, score. We have got a vector. This one of scores, and we want to assign the grades for these scores. Now we can have we can say grade if score is greater than 100, comma, invalid. If else above 90, A, 80, B, 70, C, 50, D. Then here at the end we must have a default one. So a default one is F. That means if all these have failed, are false, then we must return the default grade F, which is something like maybe fail. Okay, or could put here maybe ungraded. Then cut, that's print. Now return the concatenated string, scores, score, enter new line, grades, grade. So it means it will print the grades and scores. So on top, because we're saying enter new line, we'll have the scores on top, and then the grades, corresponding grades at the bottom. Let's run. So if we see that the scores, there were these ones. So 85 is B, 62 is A, 91 is A, 45 is F. 78 is C. If you've got not available, then it will be again not available. It's something like missing, so it will not assign anything else. 120 is above the range because we said we should have, if it's above 100, a score above 100 is invalid. This is like a percentage. We want the maximum to be 100. So 120 is invalid score. Alright, so how can we apply such nested if functions? Maybe like to grading the test scores in a data frame setup. So we can load the data set, grade SSV. This one is this data set. So we've got the ID, sex, age, and then we've got 6 grades, 6 subjects, 1, 2, 3, 4, 5, 6. So we'll be using this data set for the entire of this tutorial. So we've got 6 subjects, and then we've got the IDs of the employee or the students, and then their sex, male or female, and their ages. Okay, so let's proceed. So that's the that's one. Let us load it, then we view it. So this is the one. which we have here. So you can see that exactly what we had. So it has got it's 1 up to 7 because we already, which is displaying here, but it goes up to 200. So there are 200 observations or employees or students, and then we've got 900 columns in total. As we said already, we've got 6 subjects, and then plus these 3 ID, sex, and age. Okay, so to analyze these 6 grades. Okay. All right. Now, if we go from here, calculate the average age. So here, to calculate the average age, we use mutate. That's why we wanted the dplyr. So the mutate will be found in dplyr, that is in the database. If you didn't load the database or dplyr, mutate will fail. So mutate, it means you apply on a data frame T1, which is the one which we have here. That's this data frame, T1, and then average. It means it's a new variable. Add to this df1, and then after adding the result, change this df1 to another new table, which is df2. Otherwise, if we did not do this assignment to df2, then it will change this df1 and change it all together. So we want to maintain the df1, and that's why we're using the data frame 2. Now the average will be a new variable added, and then round, we're rounding to 2 decimal places, and then from here, that is, we check my other videos on the higher order functions. So the mapply, that is multivariate wise apply, or multiple wise apply, multiple list, for example, multiple vector. So sum is the function that we're doing, and we're working on df1 that's up to 9. We're starting from, df1, we're starting from 4 because this is data frame, so it has got 2 dimensions. The first part is rows, so we take all the rows and then just consider a column. So this is a column 4 because we consider all the rows, a column 5, a column 6 up to column 9. Why? Because we want only the 6 grades. So that's 1, 2, 3, 4, 5, 6 grades. These grades which we just want this. So that's 1, 2, 3. We exclude these 3 columns. So we start from column 4, 5, 6, 7, 8, 9. That's why we started from mathematics. So we started from 4 up to 9. Okay. So when we have got just a dot, we have clear here, blank, and then comma, it means we're considering all the 200 rows. Okay. So if we apply the multivariate apply sum, what it does is all these vectors, because they will be vectors now, because we've extracted from data frame using a comma, we're extracting, that is, we call it slicing, data frame slicing. So we've sliced it, so we have now 6 columns, and then these 6 columns, when you say apply, it means each column separately will have a sum, and then those sums which we have for each of them, each of these ones, those sums, there will be 6 sums. Because of the multivariate apply, these 6 sums will add up together. So when they add up together, then we'll have the total of okay, for this one, for the first one, df1 4, we'll have a sum. This one will have, so we'll have 6 sums, and then we divide by 6 because we have 6 sums. So what it means is, if we take any row, it means we'll have, if we take any row like the first one, what we're saying is we're adding this. So 1, 2, 3, 4, 5, 6. Okay, sorry for mathematics. So 1, 2, 3, 4, 5, 6. Add. They divide by 2. If you add divide by 6, if you want the fourth, this female, then it's these ones. Yeah. So it means 71, 8 up to 89. Add divide by 6. That's what the mapply is doing. Okay. So when you say mapply, that's what it does. So check my other videos. That's part 3. This was part 3. The previous one. Okay. Just before this one. This is part 4. So check all my videos on the functions, starting from part 1, which was the anonymous lambda functions, but 2, the factory functions, and S3 methods. Part 3, that was these higher order functions, the mapply, arrow apply, s apply. That's arrow is list apply, s is simply apply, m is multivariate or multiple apply, yeah, and the like. And then this is the last one, because that was higher order functions, but now this is the advanced logic functions, conditional functions. Okay, so. Okay, now if we do this, if we run, let it be run. So what we'll do is, if we can view, we can come here, it will be here. That is df, we have got df, what we've opened is def1 and def2. Okay, so we're already def1, and then we've done def2. And so far we've got grades and scores, which we were doing in the beginning. Okay, let us see def2, def1 is this one which we have already here. Okay, if I do again, it will just open the same one which was already here. But df2, this is the one. So now if we see df2, we'll see that we have the difference that it was computed the average here at the end. So we can see that we have the average here. So it has done this one, add divide by 6 to find the average. This one, add divide by 6 to find the average here. And we have rounded here, round to 2. That's why we have them, all of them rounded to 2. Otherwise, there would have been so many decimal places when divided by 6. All right, let's proceed. Okay, so we go on, we create now a function now. So we start now the higher order function, the advanced functions. Now if we want to apply a function, a grading function, so that we can just be running this function on the data set, on the data frame. Okay, let me maximize here. So what it means is, we'll just say, I'll run from here to here. We'll just say grading, then function, x, the argument, then x will be the score in this case. So whenever we have the data frame, then we'll just have to choose the one which we want, the column that we want, or it can be one column, or it can be multiple columns, or we can filter, or we can select from the data frame. So we can subset and take a portion of the data frame, and then or take the whole data frame, so that we compute for all columns, whichever, or just two columns. But this function will be the same function which we used to calculate to do the grading. So which means in this case, we'll just put the one which we had before, only that we'll put xxx in terms of, instead of putting just score there. And then this was not like a function, we just used an if else function here, a name, like without a name. But now we have a name which was an anonymous function, but now we have a named function which is known as grading. So we can call grading now. This will be just as if else was not kept, was just cached. But this one now we can be running it. It will be stored here. Okay, so let me run it. If I run, it will come here. So we have here grading. You can see we have it grading here. That's that function. Okay, let us see now what do we want to see now. So we see that now we can use this grade now, this function. Let me maximize here. Okay, we can use to, maybe we can apply on this one. So we see that we can apply to a data frame. So we say df3, that's another new data frame, because so far we have got df2, df1, and df2. Okay, and which we have them here. So you can see here already I've opened df1, df2. This is df1, this is df2. df1 was the original one, just with 6 grades. But this one now we've added, now the 10 columns, we've added the average here. The grading is that function. Okay, now we are adding now a data frame 3. So we mutate, we use the dplyr, the tidyverse functions. Mutate, what it does is mutate is how we transform and create add a new word, create a new data frame, and add or do something, do some transformation to the data and save as another data frame. That's mutate. So the two which we have here, which is this one I was showing here, now we want to add the grade. So when we're adding the grade, M apply, that the other one was the M apply, that was multivariate apply, but this one is list-wise apply, not multivariate, not multiple list. Okay, so multivariate is multiple list, but here is multiple list apply, but this one is the one list apply. We could also S apply, simply apply, so it converts into a vector, like a one the result, if it is possible. Okay, so now here arrow apply, list-wise, then average grading. So which means when you say list apply, average. Okay, because here we said mutate, it's expected to do some transformation on this data 3. So here when we say grade, it's creating a new column which will be named what, grade. Yeah, and then this one, now how is this calculated? It's transformed from the what, average. How? We are using the grading, so that we grade this average to get this one. Why? That's what we've been saying here. So we say grading whenever we've got x, that's a vector or a data frame or whatever, as long as numeric, then we apply this to grade that. So when we use that function here, when you say arrow apply, use this function, apply on this you see that arrow apply, you must okay, if you see that this one, the average is just one vector or one list, a column of the data frame. So when you apply there, it means you get the grades. Okay, let me run it for each. Okay, let me run. So we've added there, you see. Okay, here we're not seeing the results, but here we'll see that we have data frame 3. Okay, so we have, okay, let me just use just let see it like that. So you see that here now we've added the grades. So you can see that you see that this one is yeah, okay, you can see it. Let me do like this. Okay, I can push this one to the right like that. So you can see that for so we've seen that these first 3 they failed, they got below average 50, but D is a pass, like that. Yeah, you can have also maybe B, the credit distinctions, A, the distinctions like that. Yeah, up to 200. So it has done correctly applying by using the function here of grading. Okay, let us move on. Let us perform some filters to view our data set. So if we perform like here, we want to perform the data frame filters and selections. Filter grade A only. If you want grade A only, let me run line by line. If you want grade A only from this one, from the D3, so it's this one. I can reposition it at the end here. Okay, so if we want in this D3, this was the grading function, I can close it. This one is the diff1. Now we don't need it. Diff2. Now we're at D3. So now what we want is we want to subset the grade A. So all those which have got grade A only, we filter them. If we want to do that one, we use subset, and then inside again subset. So this subset, okay, it is filtering the grade A only. So if we run, we see now. If we see now, we get D3, because what we did is we just said grade A. Okay, so D3 will remain as it is, but we have to see grade A. So there will be grade A here. This one, this one, this one is this one, grade A. So if we see this one, we'll see that it has filtered and there are only 3. So it's only 3 who got A's. Hello? It means it's only this A, and only 2 males, and only this one female got an A. The other 2 males. Those are the ones. An A is above, I think it was 90, according to our grading function system. So that's why we can filter those who got distinctions, which means out of these 223 got distinctions. These are the ones. Alright, if you can filter this one, you want to filter this one. Because last time we were filtering the grade. Okay, that was grade A only. Let us filter also the grade B only. If you want to filter grade B only, it's the same thing, only that way grade A will go to grade B. So if we run, then we'll see that grade B only, we have grade B. So there are 4. There are 4 only. You can see, yeah. So these are the ones who got grade B. Okay, we have got male, female, 2 females. Those got B. All right. If you want those who got C, it's the same thing. We just put C here. So I should not waste a lot of time. Just C. So if we go to C, there are 8. So these 8, they got C's. There are 8 of them. Okay, so that is 8. Yeah, these are the ones who got C's. All right. Let us see now a combination. If we say like that, we want those who get either grade A, B, or grade C. In that case, we say subset here. So this is also grade BC subset. So it means what I'm doing is, in this case, we're not changing the original DF3. Mutate is the one which is changing, but when just a subset, it just selects and filters from the table mutate this one, but it remains the same. But what happens is that when I put there grade 3, then it means it will store into this one, BC. Okay, now subset. If we say either B or C, because AND, there will be 0. There's no one can get both grades. And we use the AND sign, but here we'll use this is the vertical tilde. That's the divided by that means OR. We do the same thing, I think, in many computer packages. Yeah, we use this for OR. So when we run this one, then it means it will give both A and a B or C. You can see B or C, there are 11. So you can see that here, some of them there will be B, and some of them there will be C. See, some of them will be 11. Okay. All right. So that is the F3, grade B, C, grade C, E. Yeah. All right. So okay, because I was sorting, it's fine. I can just do quickly. Let me just restart it. It will not take time. I think I did an error operation when I was trying to sort. Okay, so to just come back quickly. So the object no longer exists. It's fine. I can just remove them. I can just remove them. We don't mind. Okay, let's proceed. Okay, so okay, it's fine. It's fine. I can just what I do is I can just land quickly. Like that. We go up to where we are. Okay, where are we? I'll run again. Where are here? Yeah, so mutate, perform grade. Yeah, A, C only, B and C. What about, so we've just been doing B and C. That's where we are. B and C here. Yeah, so I was trying to sort there. I think okay. Now, if we go to now, where is it? Okay, I wanted something else here. What about if now here we want B or C like above, but we want all the subjects columns excluded, so we don't want the 6 columns. So we don't want these ones, mathematics up to chemistry. We just want ID, sex, age, and then we jump to average, grade, and average and grade. We just remove these ones because we've already transformed, we've computed from these 6 the average and the grade. So we just want to see these 3, 5, and these 2, 5 columns. Out of these 11, we remove these 6. Okay, so how do we do it? So we say it's the same as above, but 2. Okay, that's now the one which we had above exactly as we had. Then we just put select. So inside we have got subset, then subset that one. So it's continuing. That's why I'm indenting here to show that it's one line. But even if you don't indent, it's okay. But this is one line is continuing. Okay, so it means inside we have got select, ID, sex. So 1, 2, 3, 4, 5. So just mention the and you put in a C vector, coordinate vector. Okay, if you do that one, it means you have subset in this data frame. Subset gets B and or C, and then comma select. This one select is you are selecting columns. For subset you are filtering following a condition. Okay, so let's run. In that case, now what we will have is we'll have now BC, but 2. We've got 12 now. See BC, we are 12. BC2, we've got 12 again. Okay, so they will remain the same, but the difference will be because the columns. This one will have 11 columns, but this one we've removed 5. We've removed so we have just now 1, 2, 3, and then we've removed those 6 in the middle, and then that end. So but there will be 12 of them. Hello, yeah. So that's how we're going to use the filter functions. Okay. Finally, before we move on to another, let us move to other advanced. This one is just starting, but we're going to more advanced functions. Let us see now. What about if we so stay tuned. Okay, for filter, just like above, we've done above, but do it condition it on females. That means it will be the same thing we had. So the subset and select, you can swap, you can put anywhere. As long what is important is if you mention that this is a select argument, this is a subset argument. All of these was a side subset. So you've got subset inside, you've got a subset again, and you can have a select. Subset, that's one way you do some logic. Subset is for conditions, for the logic, whereby the select is for columns. Okay, so it does not matter. Like here, we started with the subset and then with the columns. It does not matter. Here we started with the columns and then subset. It does not matter which one you start. Yeah. Okay, but the data frame 3 must always be the first one. If you want df3 to put it anywhere else, then you must put first to say data equals df3. Okay. So now what we're saying here is the same variables we had, but we've just added the same that one we had, which was grade B or grade C. Then we must put in bracket because and will work on. If we don't put the bracket, it will work on the female and the grade B, not C. So we must put this grade B or C in the bracket so that and is operating on that one. I think you know about set theory, union intersection. Okay, of 3 sets. Okay. Now what you have here is. What we do is sex is female and that. So if we run at what we had before, so last time we had 12, now we'll have less. We had 12, but now we'll have less since 6 because it means the other 6 were males, the other 6 were females. So it means in this case, all of them, these 6 will be females, which are in that condition of having B or C. All right, if it was male, then we would have the remaining 12 as 6. Now let us go to another function 2. That what we did before was using using the nested functions. So that's what we'll be doing here to do the nested function. If else, we call them nested. Okay, what about if we for 2 now, if we want to use case when? This one we use for multiple sequential conditions. For example, like you can categorize the age groups or any other categorical data. So that's an example, just an example. We don't want to use for categorical data, so you can use case when. So what we'll do is, for example, we will say data frame age. Okay, so we're creating a data frame. This means create a data frame, and then this data frame has got the columns name and age, and this first column C, it means has got these names, and then the age has got these ages, and they must match. If they don't match, somewhere it will give just a missing value. Okay, it may give a warning and it give a missing value. Okay, where it's missing. Okay, if age. Okay, now if we run this one, this data frame, if you want to see it, that is the df age. You can just see it how it is. So we have here df age. I think it's the first one. Yeah, 8 observations. So it's only 2 columns, name and the 8 observations. 8 records, 8 rows. And we have the first one we said name, and then we entered these names. Alice, Bob, David, F. And ages, we entered these ones up to 110. And we've got this deliberately negative 20. These are for data cleaning. If someone has made a mistake, you must be able to detect this. Okay, so I've put deliberately a negative. Let us see what this function is doing. So what we'll say is, let me maximize here. So we'll say dfh cut. So we're categorizing now. So you say mutate. We're using the dplyr. Then you know what a mutate does. You create you use the data frame which we have above, this one. So it means here it will read this data frame, what we have here, and then it will create a new column. You cannot create only one, you can create as many columns. We'll see when we go to other examples below. You can create many columns at once. Okay, you can do so many transformations in this mutate. There's no limit. Okay, you can do maybe you can create maybe 20, 50, 100 new columns in just one mutate line. Okay. So now here, then you say case when as a function in the dplyr. So when you use the case when, then you put the conditions now. So when age is greater than 0 and 18, which we mean by when age is and, it means between 0 and 18 minor. If it is between 18 and 65, add that. Between 65 and 99, senior. So this symbol means assign. This is assign. So it means if we or allocate or assign or attribute. So when you've got this condition, then whenever you see the age is in this condition, that's the case when it's in this case, then the age group will replace with the minor, like that. So, but if all these ones are not there, then if it is missing, it will put not available. But if it is you have entered something but it's not a correct value, then it will say true. Okay, the computer will return the true. So if it turns true, then we set a default case. It means none of the above. So there's no match. So we don't want the computer to complain. So we put invalid so that there are no some errors or like that. That is to avoid garbage in, garbage out. You know, these are the how we protect the program from maybe crashing, okay, or getting confused. So we use something like this. We call it error handling techniques. Okay, so let me run it. Okay, so if I run up to here, so this is a function. And it's a function, of course, but it would not be a named function because we're just saying mutate and then put that one. But we'll generate a function down here. So let me run. So this is a function, which means we have just a function, but it will not appear here because it's like a named function when you use just like that. But if we assign it to say, okay, we'll see down, that's when we can have. Let us print now to see what we've done here. Because at first we had the DH, which is just like that. But what have we done by doing this? We have added the age group, and it has used these cases. So we call it case when. This is a variable in the dplyr in mutate. So you say mutate when we go to the data frame, and then you use case when. Then that's another way how built function of case when. Okay, so what will happen? Let us run and see. We'll see that we have categorized correctly case when. That is the DH categorized 8. You see now this one was 2 variables. Now we've got 3 variables. Okay, so why? Because now you see this one was just like that. Then we added another column. That's what mutate is doing, which is a grade, which is not this one. And there was another one. No. Okay, let me remove some other things. Remove grade, remove. See this one. So we have got the age group. So you can see that at least this one which was negative 20, it says invalid. This one is minor. This is adult. Elizabeth is senior. But if you have got the age greater than 99, we said we didn't want people to be 100 years or old. So we are dealing with people up to 99. So starting from 100 going up, it will say invalid. Negatives, it will say invalid. Alright, but minor, 5 is minor. Okay, 12 is minor. Okay, but above 18, so it has done correctly. Okay, that's the case when. Let us apply an advanced function. So to the data set. So application grouping categorical variables in a data frame. So we can take advantage of this. We're just showing casing here, but we can take advantage of this and be using it to So it's not only about age group. It's not only about the ages like this one, minor, adult, or age group like this. You can have like maybe you had maybe for example in one of the videos, if you can check, I also did a similar thing. If you have maybe grades, then you can assign maybe A, B, C, D, E, something like that, or F. But also if you can have maybe like the not diabetes, but I should say BMI, body mass index. We have a column of computed the body mass index. Then we can categorize it into maybe overweight, underweight, normal weight, something like that. Okay, so in that case you need to use these techniques. Okay, now grouping, for example. So a variable grouping, which is a variable grouping, and we are saying grouping up to here. So what we say is grouping function tf is a data frame, so which means we pass the argument data frame, and then we have got also the x variable, and then which is a vector. This x will be a vector, so it will test that vector, which is we're saying like maybe the here will be like the edge. So it will test that edge and see if the edge is between 18 and the 20. Then it to say okay, the edge group is 18 to 20, like that, less than 20. If it's like that, this means if edge is greater than 20 and edge is less than 23, which means it's between 20 and 23, including 20. Okay, but not 23, including 23, but not, or including both 23 and 25, between and including both. So which means included both. But these two are not including 20 and 23, which means 20 is not in this class. 20 is sorry, I mean 20 is not in this class, but is here. Similar 23 is not in this class, but is here. But 25 is and is also in this class. All right. So if true, that's the default, as we said. If it's something it's not missing, if it's missing, it will be not available. But NA. But if it's different from NA, not missing, then that one it will have to put here invalid class or invalid group. All right. So if I learn this function, then let us use it now to categorize our data set. So for example, if we say df4, because we know our df4 already, let me go back, our df4, because I close them, df4, oh, we are creating a new one. df4 is a new one, but we say grouping df3, so I wanted to see the one which we have already, df3, which is this one. So this is our df3, which had average age, or computed the average age, and also grouped the what? The grades. I mean, not average age, the average grade, and then we have put the what? The grades there. We did last time. Now we want to use the edges here, and then put and add another column here, which should have the classes age group. Okay, so that's what we're doing here. So if we run, so we use grouping, that's that function, and then we pass in the data frame and x. So the data frame is d3, x is the edge. But if we just put edge here, it will not work. If we just put edge, it will not work because edge is inside. We must say df3 edge. Okay, we must mention it by what? It must be callable by iterable by what? df3 if it's data frame, and then $ edge. Okay, or if not, you could use df3 then square brackets to index it, like slicing. Then you say comma for rows or rows, and then column. Then we count what column is here. Because here we've got 11 columns. It means okay, but this is the edge, so it will be column 2. So we can just say df3 then is comma 3. So it's the same as df3 then $edge or comma 3 inside square brackets. We'll do the same thing. So let us run. Then we see that we've got df4, which will be again 200, but what we've done is this was 11 variables, but this one now we have 12 variables because we've added at the end here, we have added this one, the age group. So you can see that it has done correctly the way we wanted. So that if age is 23, it will say 23 is here, and if it will be 21, it will say is here, and if it is 19, okay, that is there. Okay, let's see someone big, 24, then it will say is in 23, 25 correctly. Yeah, so but 18 is in that one, in 18, 20. Okay, so we've done correctly, all of them 200. Okay, let us see the way we did like last time to perform the filter, so that we see if we want the over 12, over 20. So we subset, you remember I already said about this. Then you say grade is A, we want grade A and over 20. So we want over 20 and grade A. So what you do is you say subset, that's for logical, for filtering. So for filtering rows, you use subset. So you say grade A, that's for filtering rows. Subsetting is for filtering rows. While selections, you are performing the data filter, and the selection filter is on rows, which is like subset. Whereby the selection is on select, which is on columns. Okay. So here we're filtering the rows, whereby the columns grade A, grade is A, from all the rows that the grade is A, and then the age is greater than 20. So if we run, this will be what would we have? So over 20, this one, only 2. So you can see that there are only 2 who are in that category. Okay, why? Because these are the only ones who have got ages greater than 20, and at the same time they have got grade A's. They got distinctions. So they got distinctions, and then so these are the only ones. The ones who got distinctions, which is A, and they were above 20. So they were only the males, right? Yeah, no female got distinction 20. Got distinction for those who were above 20. But I remember there was a female who got distinction, but was below 20. Okay, let us see. We will see. We have one. Yeah, so that is over 20 again, but now B. So grades B. Okay, so we do the same, which means just here grade B. If we run, then we'll see that we have over 20, grade B. So this will be over 20, and then grade B, and over 20. Okay, there are also 3 only. Let us see another one. What about if we have got this one? This one is, we have under 22 now. Okay, and either, that's why we see that female now. So under 22, there was one female who got distinction, because I know the data set. So it will be in here. So under 22, and then got a distinction, A or B, and then grade A or grade B, and then you put and age is less than under 22. You put this one is a logical, you put in subset. Okay, if you wanted the columns, you put select. Okay, we'll see the columns. That's this one. Okay, let me first run this one. The subset is the filtering the rows. If we run, so see under 22, A, grade A, and B. So there were 4, and these 2 females, one of them got a distinction, another one is B. Let me see. Yeah, so it's this one. So when we were checking those who got distinctions, because you remember we had 3 distinctions, but over 20 they were only the males. So below, this is 19, is below 20. That's why it was not appearing on that set. Or that's why it was not appearing on this set. Okay, yeah. So now we have got under. So we have got these ones who got grade B and A. There are only 4. Let us see now this last one before we go to more complicated user-defined functions. Okay, now example number 3. So far we've done this 2. Let us go to number 3. But before going to number 3, let us see this one. So this we want to filter all the. We want to filter the grades A or C only, and they must be under 22. So it's under 22, and grades B or C. Okay, it should be B or C, not A or C. Okay, so here's B, grades B. Sorry, correction. Grades B or C. So either grade B or C, and then B or C, and then under 22, and then that's exactly what we had. Okay, no, it's similar to the one we had before. But this was A and B, but now we want A and C. So here was the A and B, but now it's B and C. But now we have this condition and the age 22. And now we want only females now. So we put and sex is female. But also we want with all subjects columns excluded. So we want to exclude again. So we select and then just put those 6 ID, sex, age, average, grade, and age group, and remove, so that we remove the original 6 mathematics to chemistry grades. Okay, so you can see selects the columns. Okay, while subset is the one which filters the logic. Okay, so if we run, what we have here, we'll see that it's this one. So it's under 22, grade B or grade C, and only females, and some columns removed there. So we'll see that we have removed all the subjects. So we have just ID, sex, age, average, grade, age group. We've removed because between age and average we had 6 subjects here. So we say now, because we already have the information, we just want the overall average, then we just have removed them. And there are only 3 who are in this category, who are females, and then the grades B or C, and then the ages under 22. All right, so that is about filtering, selections, and that. But let us go to now a bit more complex now. Okay, let me just do like that. Okay, we're going now a bit more complex. That's example 3. So what about to calculate a median function? Maybe let me move here. So we want to let me save. So we want a user-defined median. So to define a median method, for numeric vector x. Okay, so we want to calculate the what median. Okay, of course we have the inbuilt median. If we just say median, it's already there, which will calculate the median, which is similar to what we've done here. Okay, but the logic will be similar. But let us make our own function, because we want just to learn how to construct user-defined functions. So you can make your own user function, which is even does not have even a counterpart in the built sense. But median, we already have the built one, the built-in, but we just want so it ends here. You can see all this is for the median. So what we're saying is, okay, let me go up like that, or let me make it a bit smaller like that, okay, so that it fits on one page. Like that. Go up here. Oh, yeah, like this. Yeah, so it's starting from here. Yeah, it's fine. I just push it a little bit up like that. So it's from 125 up to 139 here. So user median. So this will calculate the median of any vector. Okay, how will we do this? So this is example 3. Okay, then we have also two more examples. Stay tuned. Okay. So user median. Okay, so function x, which means this is a vector. So if length of x, we take the length of x, %2 equals 1. What we do here is, when we do the percent, is the modulus. It means if the remainder is 1, when you divide by 2, when the remainder is 1, it means this function, this vector, the sample size, or the count was odd, is odd. Okay, because the remainder is 1. So if that's the case, then we know how to find the median. What we do is we sort the data set. So this is x. We don't want to transform the x. The x must remain as it is, because if we put x again here, then sort, then the x will be transformed into this sorted one. But we want x to remain as it is, and generate another y which will contain the sorted x, decreasing. That is from starting with the largest one, decreasing false, which means it does not matter here. You can do decreasing false, or you can do decreasing true. Okay, so decreasing false, it means what you mean is you start from the small number going up. In other words, decreasing false means ascending. Okay, because if decreasing is true, then it means descending. Okay, so here this means ascending. Now if you, after sorting, then because it's odd, it means the one which is in the middle, which is the one of the position, we take 1. If there were 9, they are odd. If there were 9, we add 9 plus 1 to make 10. It means we divide by 2, which means the one which is at position 5 is the median. If it was 9, if it was 11, then 11 plus 1, which 11 plus 1 will be 11 plus 1 will be 12. 12 divided by 2, which is 6, which means if there were 11, then the position number 6, that's where we'll get position number 6, that's where we'll get the median. Okay, so how do we do this? We say median, we assign to median, y is a vector, so we slice, we use the position inside, so we say y is a vector, then we say y, we want now to check to take the position, because y is a vector, is a list, not a list, is a vector, has got components inside, the elements. Okay, now we have got number 1 up to this odd, up to n, when n is odd. Now we add n plus 1 divided by 2, we get a position. That position, this one, n, is what we are finding it by length xy, because we don't know that vector. We can pass in any vector. You can pass a vector with 6n, or with 10, or with 20, or 100, or whatever, but or 106 or 105, it can be odd or even. So that's why we just say whatever you pass in, it should detect what the length, which will be n. Okay, so then plus 1, then divide by 2, that will turn the position in the middle. Then we read the y slice of this this value, we read the y there after sorting it. That's all. So the median is just obtained by these 2 lines. Why? If it is odd, this is testing if it's testing the condition, it's conditional. So if it's odd, yes, then these 2 lines I've highlighted are the ones which compute the median, which you return in 138 here. Okay, because this part is if this one is true, if it is odd. But if this is false, then it means else. Then it means we'll have to do for even case. So whether you do the odd part or the even part. After that, you return the median, so that when you're calling this user median, it should be returning the median. We call it the return value. Now here, these ones, we could put them here in the function or not. Okay, we'll do these ones down here when we're calling the function, but I just wanted it to automatically. So this is not part of calculating the median, but I just want to say, while you are calculating, when you pass on this function, it should, when it's giving us the return value, it must also tell us to say n is odd or n is even. Okay, and then enter a new line, initial vector x, so which means it puts the original x as it was entered. Enter a new line, sorted what, line 3 sorted vector, then it puts what y, so that we just see whether it was odd or even, and the initial vector, and after sorting it, and then it will return, and the median, which it will return here. Okay, so yeah, but if it is even, then now you have to use two positions. So it means what we're going to do is we'll do the same thing, we sort the way we did here, ascending to the first, and then we do the same thing the way we did there. We'll do the same thing here, only that here it was odd, here it will be even, but the rest will be the same. But this part here, what will differ is this one, that we are taking at this position, but for even we take at this position. So we use half the positions, two middle positions. What it means is if we had 10 is even, then we look at 10 divided by 2, the fifth position, and the sixth position. So it will be this, the fifth position, n divided by 2, the same one, n divided by 2, we look at the next position, which is the sixth position. If it was 12, this will be the sixth position, and we look at this 6 plus 1, the seventh position. So these two, these values at these two positions, the first one at n over 2, which is here, n is the length x over 2, we read the y value at that after sorting. Then we read another y value of this one, the n over 2 plus 1 after sorting. These two values, this value of y there, this value of y, the next value y there, then we add these two values. After adding them, we take the median half. Alright, let me run this function. So if we run, okay, which means we've run now, we have the function, the user median function, which is this one. So we have our function now. We've running, we have this function, which is the user median function, is in the global environment. And then this function, yeah, it will return as we've said, like this. Okay, now let us use it, test the correctness. Okay, so we have vector 1 and vector 2. The other one is odd, the other one is even size. So you see here, what we do is they are not ordered. So when we pass over to that one, it will sort ascending. After sorting, and then it will count to see whether it's odd or even, and apply the logic correctly. So you can see these two, we've tested it on the one vector which is the odd, and another vector which is even. Okay, if I run, so you can see that, it is saying n is odd for the first one, which is correct. It has counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it means n 11 plus 1, 12. So it means the 12th one. So after sorting this one, so the initial vector is that one, which is that one, and the sorted vector, so it has sorted, so it will be 1, 2, 3, 4, 5, 6. The sixth one is the one which will be the median, because here we got 1, 2, 3, 4, 5. This side we have 1, 2, 3, 4, 5. The mid one will be this one. So we're using those definitions. Whereby for the second one, it will say n is even, and the initial vector is this one up to 16. Now after sorting it, ascending, so you start from 1 for up to 16, and then since it is even, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will look at the fifth, and then the sixth. So it's 1, 2, 3, 4, 5, and the sixth. So this will be to mid one. So you add 19 divided by 2, which is 9.5. So the median is 9.5. Okay, you see. So done our. So you can put in a. It means this will be working on any vector you are doing. It will be doing. It's not only these ones. It's on any vector. Any vector you will be doing. Okay. Let us compare with the inbuilt one. So you see, if we just put the bracket outside, we mean force it to immediately display. Okay. Otherwise, if we don't put outside, it will just line quietly. Okay. So which means median. This is user median we've made, but inbuilt there's already a function median. Let us run it and compare the results. We see that if you just use the inbuilt in the R, indeed 7 for the first one, and indeed 9.5 for the second one. And this one we're using the inbuilt, the one which is already inbuilt. But here we're using the one we did ourselves, the user median. Alright, so it's correct. We're checking the correctness. Okay. Accuracy. Now let us move to application of this median. So how can we apply into a data frame? So this now we apply to a data frame. Okay, stay tuned because we're doing more advanced functions. And the next one, number 4, is the switch, using the switch. So we're going to use the switch, and then before I come to the switch, this is the switch. Okay, then we've got other again. Okay, that's for the switch. Okay, so before we go to the switch, let us see this one, application of the what are we doing here? We're doing the if conditions. Okay, so the if conditions. Okay, so what we'll do is df1 read, so which means we can read that one, the one I showed you already at the beginning. Then view, you can view it, and then let me run just this one. So if I run, so it's this one. So I view it, so it's this one, which is the one which we said at the beginning. Okay, now here, that's the application now on this data frame. So we have this data frame, and we want to calculate the median scores for all 6 subjects. So we have got these subjects: math, English, biology, computer, all these. We want to calculate the median for all these at once. Okay, so that you can take use of our function that we've created here. Which is the user median. This function which we are doing, this user median, we did here %2. This one. So we use it, and then how we say print begin a new line, column names def1, which means you've got these column names, which means it will be saying math, English, biology, computer, physics. That's the column names. And then 4 up to 9. Why? Because this is number 1, column 1, 2, 3. So start from mathematics, 4, 5, 6, 7, 8, 9. So starting from 4 up to 9. Otherwise it would include 6 inside. And if you include 6, it would crash because it cannot calculate the median for 6. Okay, but for ID and age it will calculate the median, but we don't want. Okay, but for 6 it will not even calculate. It will complain because this is a character, it's not numeric. Okay, so if we come here, that's why I was specifying from 4 up to 9. What we do is, that is for single valued operations, conditions, and performing different operations based on a choice. So which means you've got operation, and then as a function, and then the function we've got choice x, y, and then switch. This keyword, when we've got a switch, then this choice here will be passing a choice here. If we put add here, it will work on with an add. If we put subtract, it will subtract, like that. Modulo. Power, it will put power, like that. Stop if it's invalid. So then xy, it means it was operating on this is the first argument, the second argument, or operators. First operator, second operator, and then in the not operator but operand. Okay, so first operand and the second operand, and then choice, it will be the operator. So here the operator is add, the operator is power, which means these two operands you do power, like that. The first one subtract, the second one add, like that. So if you define like that, this is like maybe you are making like a mini calculator. Yeah, but you can extend this to as many definitions. With the power here, you can have maybe cubes, but cube will operate on 1, but you can have the ones which operate on 2, as many as you can have. Then if you run this one, you can test it. So that's the use of switch. If we test it from here up to here, okay, like that. So what will happen is all these ones will work correctly. Okay, let us run. You save. Okay. Okay, so if you see the answers, so 20 plus 3, 23. 20 minus 3, 17. 20 times 3, 60. 20 divided by 3, like that. 20% 3, that's the modulo. You see, you divide by 3, then 6, the remainder is 2. But integral division, that's just 326. Okay, and then the power 20 to the power 3 is 8000, because 20 to the power 2 would be 400. 400 to the power 2 again. I mean, it is 20 times 20 times 20. So 20 times 20, 400 times another 20, 8000. All right. Now, but if you do these ones, they should throw an error. Why? Because that's why here we said stop invalid operation. So stop invalid operation, that is if you put error for no match. If you put something that is not here or not defined, it must give an error. So you put stop for error handling. Okay, so you put stop because it will give it to show here that here there's an error. So you stop. Okay. Similarly, this one, if you do like maybe operation like 20 permute 3 permutation, so it will not do combination and permutation, combinatorics, it will not do. Unless if you want to combinatorics or permutation, then you must define again here combination, permutation of two operands. Then you explain here when you say 5 choose 2 or 6 permutation 2, then you can define them here, then it will be working. So you can just extend to this definition. That's another way how a calculator is made. You see, like a switch. So a calculator usually is a switch or logic gate or switch. Okay, now let's apply this one, this logic gate, this switch, now to user-defined Pearson. So this is the user-defined Pearson correlation function. Okay, so this is very interesting. Okay, we know already we have got the Pearson correlation function in R, but we want to do our own user-defined. So before we go to advanced thing, we'll start with a straightforward, then we'll go to advanced. Just a few minutes. Okay, so application user-defined Pearson, so which means moment. So this is a function, which is we'll call it moment. Then function choice xy. We use a switch, and then choice we can have pq, which means it's a product moment, and then p square, a square moment, and then q square, that is we call it a square moment for y, second moment for y, and second moment for x, whereby this one xy is a product moment. Otherwise, stop the operation. Alright, so if we do this one, this is just a function. We can use it on the data frame like this. So let us mutate and transform the data frame. So as usual, we're using this one, we run it. Okay, so with that one we've run, and then you know it's the data frame one. I will not view it. Now is the one which we've been doing all along. Okay, I can just view it. So if in case someone has just joined, so it's this one. So now on this data frame, so we say we don't want to tamper with it, so we'll create a new data frame 5. Okay, which means we'll put a data frame 5, which is exactly as that one. Yeah, so that this was 1, and we'll get a data frame 5, a copy, okay, of this one. Okay, now we go to, after that, then now here, so we subset this data frame 5, and then we select the math and computer. So you see here, okay, this one, otherwise I can remove these other objects, the data tables, or yeah, okay, yeah, because that is object oriented. So these are objects. Okay, so now here, the select. Okay, what we want is to select mathematics and English only. Mathematics and computer only. So we want to calculate the correlation coefficient between mathematics, the correlation between mathematics and the computer science scores. How are they related or correlated? Okay, so I'll run. What happens when you do like this? It means when you select, it means to drop. It will select only these ones, and then the D5 will only have those 2 columns. So D5, you see now the D5 has got only these 2 columns. That's the meaning of select choose. Okay, now after that, then we do this one now. Okay, so what we're doing for this one, from here up to here, okay, what are we doing? The same D5, you see that here I'm making the same D5 because we're just changing it. So the D5, we're updating it. You see the way it's looking like this, then we update it. So I'm using D5, there's no problem. But if I wanted, I would have been changing D5, then D6, D7, D8 if I want to keep all the versions. But here I don't need, I just wanted to keep only the DF1, so, the original one. So from here we've made a copy of 5, then that 5 now we're maintaining it, we're just updating it. So here we selected 2 columns only from that 9 columns, and then now here we mutate. When you use mutate, okay, then you say df5, okay, it's the same one, xy. Now we're applying now this switch. So this switch will be a function of moments. So we say this moments, the pq, this and that, if we choose like that, as well as I already explained, and we use the mapply technique, the higher functions. Check my other videos. So the mapply, that is the multivariate case apply, and then on the moments, and then this function moments, which is a named function, then I choose a select, because I'm passing the choice here, the choice which must be PQ for some product, and then some squares for x and y. We'll use this one, the squares. Okay, so we select the moment, we use multivariate apply, and then we're applying it to the moments, and this method we're using is the PQ, and we're applying it on mathematics and computer. So we apply it on mathematics and computer. So this part, what we're saying is that I can start from here. So mapply, which means we're applying the moment function, which is this moment function that we user defined for Pearson correlation function, for we're using moments method, and then here the xy, we want the column to calculate the sum product, okay, of mathematics and computer, and then we'll have, so this one we put it, we assign it to xy, then comma, okay, I should say like this, comma, and again x2 I should say like this. So the x2 is for the second moments, we use p, method p2 here, and q2 we use for y square. Okay, and then the whole of this from here to here, all I'm mutating. Okay, so if we run this one, what are we doing? Run. Let us see the diff5 now. You see, what we've done is last time we had only math, and last time we ran this one, which was we had only math and computer. We extracted from the whole. So we started with, we began with, we had D1, FT1, that one, and then has got 9 columns, and then we selected only mathematics and computer, and then now we have added these 3. So mathematics was the raw scores of mathematics, like x, and computer is for y. So this is variable x, and this is variable y. This is a pair. Okay, now x and y, we find the product, so that when we add, we get the we use for product moments, and then the square of math, we do the square 50, we square 92, we square 14, we square that we will add for the sum of x square. For computer again, for y, we'll do the same thing. 63 square is that one, like that. So, yeah, 23 square 529, and then we'll add. Okay, then we have done this one up to for 200, up to 200. Okay, so for 2 it will become 4. For 9, it like that. For 0, it will be 0. Some product is 0. The product will be 0. The square will be 0. Okay, here, but 24, yeah, like that. Okay, so now if we go to, that's what this is doing. And then now we want to calculate now the Pearson from this one. So we're using the product moment, the formula, there's a formula that we take the summation, with the square of this one, we take, but n multiplied by the sum of this one. The sum of this one, n multiplied by the sum of this one, that's on the numerator, minus this one, the sum of this one, times, sorry, the sum of this one, sum of x, times the sum of y. Then on the denominator, we take n times, but we take the square root of n times this one, the sum of this one, and then we minus this one, the sum of this one, then we put in bracket square. Then another bracket inside the square root, we have n again, because of freedom, the sample size count, then multiplied by the sum of y square, then minus then the sum of this of y, and then we put in square. So you can check the formula of product moment. Pearson product moment. So when we apply those formula, which I'm talking about, then it's this one. Okay, maybe it's too small. Let me make it big. Okay. Yeah. So this was explaining above, because we have this one, that's the function, because this one is the function that we're using, and then okay, yeah, we've done the mutation here. Then now we're here, we're calculating the Pearson from here up to here. So what we're saying here, okay, I can enter here. Okay, so what we're doing here, we are, okay, this one's gonna start from here, there's no problem. Oh, but this is a function. No, it's not a function. So it's like the function is ending here. That's the moment. So these ones I can just start from the beginning here, no problem. But this one I can indent, because this one is one line, the one I was explaining. This one like that. So this is also one line. Okay, so before I did this one, I had first to calculate the sums here. So what I was calculating, okay, this one here, I ran already. Okay, so what I here. Okay, so let's start with this one. So if I run this one, what it's doing, You see this, I'm using arrow apply, so I must have a comma here, 1 to 5. If you see the D5, so it's 1, 2, 3, 4, 5. That's what I'm saying, 1 up to 5, columns 1 up to 5. Okay, and then all rows, so I'll just put blank and then comma, all rows, and 1 to 5. So arrow apply, and then I'm using this function sum on this. What it's doing is, let me run, it's doing a sum of each column, which means in other words, I'm finding the totals at the bottom here. So when I go up to 200 here, then I can add here another row to say total. So I add all these totals, all these columns. So the totals at the bottom here. That's why I'm doing here by sums, or I could say totals. So I run. If I could see that these are the sums. If I wanted to see them, what are these sums? If you wanted to see them, I can just run only there, sums only. So I can look so that you see them. So these are the ones. This is a list because of arrow apply. When you use arrow apply, it returns a list. Okay, as opposed to S apply, it returns a vector or a matrix. Okay, but the matrix apply and the arrow apply, they return the what lists. Okay, so what I mean is that for mathematics, the total is what, which was the x is this, and for y, for computer, the variable y, that's that one, and then xy, that's the product, is this one, x times y, and x square is that one, and y square is that one. You see, but if you wanted these ones to appear as the to collapse them as just into a single row or a vector, then we could use here S apply. Let me use S apply so that you appreciate, and then I use now S apply. Then I see now the sums now after applying S apply. Then you see now it would be clean like this now. So the difference that when you use arrow apply, check my other video just before this video, the higher order functions. So the arrow apply, it will turn a matrix, sorry, a list, because this is a list, these are the lists, whereby this one, the S simply it turns a vector. Okay, see now the difference. Okay, so math, computer, xy, which means here math is x, computer is y. So these are the sums. Now we use these ones to calculate the correction coefficient product. These are the moments. We'll use these ones, which we use. Okay, these ones are not the moments, but these ones are the ones which we use when we subtract from the mean. When we subtract the mean, then we get the moments about the mean. Okay, so they are not directly the moments, but they are related to the moments. That's why I'm just calling them moments. Okay, but there are moments when we subtract minus the mean, minus mu. Okay, so now let me go here. What you have is okay. What you have is now, that's this one. Now we can calculate the Pearson. So what we'll do is exactly what I was saying is the n. I'll take the length. Here it's taking the n sample size. So which will give 200. Because if I can just line here from here to here, you see it will give 200. Okay, I needed a bracket here. Okay, so I can just close, so it will be 200. Okay, if I did the whole of it up to here, yeah, so it will give straight away 200. Okay, so if you change the data frame, this will be changing automatically. That's it. So you don't have to type here 200 because that is hard coding, but just type length. Okay, so then here we mean I've just chosen column 1. I would choose any column out of any of these 1 to 5. You can put here column 2 or column 3 or column 5 because they are the same size. Okay, choose just any column, and then this one you multiply by the what? This one here, because okay. So here, if you used S apply and if you use arrow apply, they are different. If you use arrow apply, then you need to use two brackets, like two square brackets. So a square bracket, nested square brackets, another inside. Okay, so let me go back here to give an error, but let me go back to arrow apply here. Okay, arrow apply back. Yeah, so that now it's if I type sums, enter. Yeah, so that's on the list. Now that's when this will need to put 2. But if I use the S apply, then here I need to use one bracket inside here. I think you've understood why there are 2 brackets, because we say list. So now if I apply that formula, then we get all this one. This is on the numerator, is from here up to here, and then on the denominator is from here up to here, and we take the square root of that. All this will be on the denominator. On the denominator, this is a fraction. This is the numerator part, and then this one is the denominator part, where the numerator part you're multiplying and is inside the square root. This part only you have a what? These first parts only, that's why you multiply with n. But the other parts, when you're saying minus, the other parts they don't have n. Okay, of course others they remove the ends here. You divide by n there, divide by n there, divide by n there, and then instead here there will be no ends. Then instead this part you divide by n, and this part divide by n, and this part divide by n. It's the same thing because you're dividing both numerator and denominator by n. Okay, so n can be this side or this side. If it's this side, it will be on the denominator. If it's this side, it will just be a multiplier. They will multiply that. Okay, so then now if I run this one, then you see now, let us see now the column names, display the sums for column names. So display the column names and the sums. That's, you see, so we'll have the math computer. Math computer simply means xy, and then that. So these are the sums. But if you display the Pearson correction coefficient, okay, so you see that now this one will say correlation math and computer. So this is the correlation, and this is to 6. I'm using the sprintf. Check my other videos so that maybe I should not be explaining all this. Cat sprintf I've explained in other videos all this, the meaning of this. So just check there what cat is doing and what sprint is doing. That is the string, or we can call it formatted string print, which is S, which is C++ procedure, okay, or technique. So which means here 6.4f, that is for float, double percent, that's a format specifier. So the Pearson R comes there with 4 decimal places, that's 4f, okay, format specifier. So here is printing exactly this correlation pattern is this one. So you have calculated the correlation using the user function. Then higher order, last one, okay, you can check the correctness. There is already a function call, this one, that is default already in the so by default you use by default it's Pearson, the first one. Okay, so this one I put it, but you can put, that's default Pearson, but you can have also the other, you can have other also Spearman, Kendo, and like. Okay, now if we do this one, let me just run it. So that's the one which is in the belt. We just do correlation. You see the answer that we get, it is exactly the same as what we have, only that we rounded to 4 decimal places. So it cut here, it rounded here, which is 9 remains 9. Okay, now let's go to the last one. This one is the last one. The last one now. Application user defined Pearson correlation using for loop traversed on a data frame. So now I want to use for loop now. Okay, so you can use this logic. Okay, if you use a for loop, okay, so stay tuned, we're just finishing now. The user Pearson function, so you have a data frame, and then you choose x and y. This x and y for the columns on the data frame. So which means when you're finding the Pearson correlation, you're finding the Pearson correlation between the columns x and y, like mathematics and English, mathematics and geography, computer science and biology. So you have 2, it is pairwise. You can then later on you can make a correlation matrix. So these 2 you perform using the user Pearson that we want to make now. So what are we going to do? So what we're going to do is we'll be passing on these parameters. This is the data frame and these columns. Then what we'll do is the first part we'll create this one, the df, the one that we've passed into this one. We don't want to modify it, so we'll just use it and then make a copy. So here this one is whenever we see it like this, this is a create a copy. Okay, data frame. So this is just a copy. Okay, then after getting a copy data frame, then now, okay, so now we start now doing business. Let me go up like this, so that's on one page like that. Okay, let me do a little bit. Yeah, so it's on one page. I wanted it on one page. Let me do a little bit. Yeah, now it's on one page like that. So this is the function. Okay, from 230 up to, yeah, okay, so this is like that. This one line you can put like that. This one you can put in one line if you want, like that. Okay, but let me put it in like that. Okay, so we are here. Okay, now this one we subset df. Now the df, that was the original one we passed. We've just created a copy, which is dff. Okay, now we're using with this copy with dff. Now subset dff, so this one we're going to be using the same dff because we say copy, we don't mind. Okay, so subset dff, select xy, which means these columns that we're going to choose there, we're going to pass them here, so that these columns must be inside this data frame. Okay, so we subset like that, select this one. What it means is from that big data frame that we have, if it has got maybe 20 columns, we just want only these 2 columns, because when we're doing Pearson correlation, it's pairwise, it's 2 columns at a time, 2 variables at a time. So you can just be changing in this function, we'll see at the end here, to make a correlation matrix. Okay, use or a correlation plot using what user defined. So which means after selecting this one, then okay, I can just run the whole of it, then I explain. So I'll run in advance the whole of it. I've run. Let me just explain, then we go. I've already run it. Okay, so here I've explained. Here what we're doing is up to here. When we use semicolon, what it means is the semicolon here, what is doing, it means instead of putting them one by one line, you can just put them in one line with semicolon. Like even here, I could do like this. It's fine. That's semicolon. Let me put it a little bit big, like this. Okay, so you can put them in one line, like this, just continuing like that, one line, one line, one line. It means if you do like that in one line, if you separate them by semicolon, it's the same thing as putting them vertically down, line by line. Okay, so what are we doing there? We are initializing, so that this was going to use them, so they will complain in a for loop if we don't have them. We must first have them, so that we can use them in a for loop below. Okay, so that we use them in this for loop. Okay, maybe let me make it a little bit small. Okay, it was too big. Yeah, so what I'm saying is there's a loop down here. This is a loop up to here. So these ones, okay, I can make it a little bit big. It's fine. Yeah. So this one, let me go down. Okay, which one have I made 0? Okay, maybe because I'm not explaining all of them. Let me go there. So it is sum x, they're the ones which are going to use them here inside. Sum x, sum y, that's y, sum y, sum x, and then the product xy sum, and then x square sum, and then y square sum, and then Pearson correlation. Okay, so these are the variables that we're going to use. Now, if we go inside here, what are we doing? We're using a for loop here from 234 up to 240. So we say j in, for j in sequence, for j in sequence up to here. So what this is doing is sequence 1 to this DFF to count the data frame that you have passed here. So this will work with any data frame that you have. It's not only working with this example I'm showing here. This function will work with any data frame. So that's why we don't have to put a hard code here, a number, but we just put the length of that data frame that you have got, and then this data frame you are choosing the first column here. This is comma 1. It means the first column. Okay, so it will loop. If it's like here, the data frame is 200. It means it will have to repeat doing this. It will loop it 200 times. If your data was 2000, it will loop 2000 times. Alright, so what is it doing here? The exam, it is incrementing each time. So what it means is this data set is 200, for example. Okay, see this one. If you see this one, so you can see here it's up to 200. If you can go down, it's up to 200. Okay, so what it's doing is, if you take maybe mathematics, that's for x, what is starting from number 1 up to 200 in this for loop. So for each of these one, what we're doing is we're working with 26, then we add it to 61. The result we accumulate, we add it to 76. The result, so we started from here, from the beginning here, it means 51. At first we initialized with 0, so add 51, then if we have 51, add 92, we have result, add 14, so we're accumulating. That's the technique we use in programming. So we started with 0, then that's we add. When I'm writing like this one, this means now we're saying for x is because we have here, we have selected from the whole data frame, we've selected only 2 columns that we're doing the Pearson. We're doing Pearson on mathematics and English, for example. So we select only mathematics and English, so that this data frame has got only 2, because here has got so many. But if we want mathematics and English, or we want mathematics and the physics, then we'll select just mathematics and physics and have only 2 columns. That's what we're doing here. Okay, doesn't mean that they should be adjacent. You can choose far apart, but just to choose 2. Those 2 now, and the first one will be x, the second one will be y. Now what we're saying is the x you'll be looking in the first column, whereby the y you'll be looking in the second column. You see x, you're looking in the first column, y in the second column. Here you put x and y, both of them. Then the x part you look in the first column, but the y part will look in the second column, because the y part is the first part is x and this one is y, or this is x and this one is y, whichever you choose. So now here, when you say DFF, you have that column. Then when you index again another one, J, this one now is starting from 1 up to 200. That's how you traverse inside here. When you say, when for example here, if I say DFF, 1, I mean the first variable, if it was mathematics, if J has incremented in this sequence up to the 200, if J has gone up to 4, then it means I'm in row number 4. So it means I'm talking about 71. That's the one which will be J will be 4. J is 1 will be, J is 2 will be like that, J is 3 like that, J is 4 like that, J is 5 will be 60. So I'm going down. So that's what we're doing here. So we're saying that one at the beginning was 0, which means here we have put 0. We add the first one, which is the first one, which is 51. Then we will have 51. We call these ones running totals. That's what I was looking for a good word. These are running totals. So the way I've explained for this one, I'll not explain for the others. All these are running totals. You do the same to find the total for some x. By the end of the day, when you run all this group of 200, then you will find the total sum of this column. You do the same thing, the total sum of English for y. Now for the product, when you multiply here, as we're doing like this, it means this one is 1, this one is 2. It means you're multiplying 51 times 69. You are pairwise, so you are multiplying pairwise. So J, as J is a column, as J is moving down, when J is on 22, you are multiplying this. When J is 31, you are multiplying this. You are going down. So which means you multiply this and then add to this and then you accumulate and find the total. So you find the total, and then, so that by the end of the day you're finding the total of okay. I can just come here. By the end of the day, it's here. Okay, so I forgot that we're not calculating only. I mean, when we choose those two in the process, it will make a table like this one. Okay, so when we're finding the running totals, we're finding this one, the x, the y, the xy, the x square, y square. So there are 1, 2, 3, 4, 5. Then we calculate. We use these 5 parts and use. That's all. What 1, 2, 3, 4, 5 for each column. 1, 2, 3, 4, 5. I think I've explained everything. So when you do this, I've already learned it. Then now the next one. Did I run this one? Did I not have an error? Yeah. I was wondering. Let me see. At the end, I must have an error. No, not an error, but it didn't finish running. You can see, I was wondering what happened. So it means this function did not finish, because I remember I highlighted only up to here. But the function is continuing. I think you remember I said, it's ending here. So, which means here, it is still expecting me to enter something, because I ran only from here up to here. You can see. But it is continuing up to where? I should have run up to here. Okay, so what I'll do is, I can just continue here. It's another way. I can just continue here up to here and run. Then it will finish the last part. Yeah, so it has finished. Okay, so it means now if we can go Pearson, but I can just run again, just to be on the safe side. So it's from here up to, okay, let me go down, up to here. Yeah, so I just run again. Let me see now. Yeah, now it has run. Okay, so this last part I did explain. I just ran this part. Or see these ones which I've found above here, I use them here. Okay, I think I remember I already explained about this before, but this time now we are using directly these sums. Okay, because so far if I can just see this sum, okay, but it will not appear here because it will be 0, because we passed in what 0, and the function is it will not give the answer here. Okay, but it will, when after running, that's when it will put in, after putting in the, after calling here and putting in here, peer user, that putting the arguments here, that's when it will run. Okay, so this function I think I explained already. So I'm just rounding to 4 decimal places. Okay, so and then use, I think this function I've already explained, divided by the square root. That's for the moment. So we're using these ones here. These results on the left hand side, we square them and do them correctly the way we did before. Now I've already run. Now let us see here now. If we run this up to here, okay, so if you run, what we are doing is, okay, let us see. So what we are doing here is correction of mathematics and English. Okay, so it means I use use Pearson up to here. It means use Pearson, and then I put the, if you remember it was the data frame, and then x and y, the variables. But now what is important is that when you're putting the variables, you must put with quotes. If you don't put with quotes, it will give an error. If you just give mat without putting this, but you must put these, because these are the names of the column names, not the vector itself, but the column name. Okay, so remember to put quotes here. Then, but here you cannot put, it doesn't matter, because here it's just on the left hand side is the way it will appear here like this. But in the formula here, this part, there must be in quote. Okay, now this one, we found that one, this one, this one, this one, this one. This which are correct. We can confirm these ones by the inbuilt formulas. Let us see the inbuilt. There's the inbuilt formulas. This one, check. The correlation, there's the inbuilt, which is the core in R, which is a score. If we check, let's see the first one. It was in Math English using our own user defined. It was 0354, which is 0354, correct. Our second one, Math and English 0354. No, I've already said it. Math and Chemistry 01440. 0140. And Biology and the Computer, which is correct, which is that one. So you can see that exactly we are correct, but it was rounded to 4 decimal places. So you can see that this, our formula, is really correct. This our formula is working. This our formula is working perfect. So it's correct. Oh, finally, the last one. This one I've already shown. Okay, you can learn the entire, because using this method, we're using this, we are the built-in. So if you want the entire, what we call it, the entire matrix, there will be 15 of them. Why? Because we have got 6 columns here, not this one. Here we've got 6 subjects, 1, 2, so mathematics up to chemistry. So because of this, then it means we have 6 combination 2, because it's pairwise. So we must have 6 choose 2, which is 15 pairs. Of course, if I can learn this one, choose 6 choose 2, we get choose 6 choose 15. So there are 15 ways, 16 different pairs. Okay, so if you see them, if you want to do using our what we are doing here, it means you have to do all of these. You have to follow this one. If you want to use our method, it means here I just did 3 like that. I just did 2 3, but now you can do for the remaining 12 to make 15, all the pairs. So this was Math English, Math Chemistry. You can do Math English, Math Chemistry up to the end. Then you start English, this one up to the end. Well, what I mean is it will be Math, then English, that's 1 2 3 4 5. Then English with Biology, that is 6 7 8 9. Then Biology with Computer 10 11 12. Then Computer with Physics 13 14. Then Physics with Chemistry 15. So there are 15. That's the 6 choose we're talking. That's the one we're talking about here. So now you can just do all those. You've done 1 2 3. Then you can do the remaining 12. Then you will find all the answers, which will be correct. But because of time, I just checked these 3. And I checked with the inbuilt. But if we use the inbuilt for the entire matrix, it is just like that. As simple as this. The score, then the data frame. Then just take the columns 4 to 9, because 1 2 3 start from 4 up to 9. This so that we have only these 6 grades subjects, and then core, and then round to 4 decimal places, and then print. So if you learn this one, then you get all of it. So there should be 15. So indeed, the correction between mathematics and English will be this one, like that. Okay, these ones, math and math itself, English and English, there will be 1 1 1 1 1 1 1. You know, that will be perfect correlation because you are repeating to be 100%. So chemistry and chemistry will be 1. So the main diagonal will be 1 1 1. And these ones, the triangle which we have here, lower triangle will be the same as the upper triangle, you know. Okay, so that's why, because if you say 6 by 6, we've got 16. If we move these 1 1 1 1 1, so which are the 6 1 2 3 4 5 6, we've got 30. 30 divided by 2 15. So we've got the lower triangle 15, upper triangle 15, which are symmetric, which are the same. That's why if we say Math English, this answer will be the same as Math English will be the same as English Math. See, Computer Biology, this one, Computer Biology will be the same as Biology Computer. Biology Computer will be the same as this one. So like that. Okay, so if you've got English and Physics which is this one. They do the same as physics and English. See? So that's why there are 36 minus 6, the diagonal, we get 30 divided by 2, 15. That's why there were only 15 ways, because math, biology is the same as biology, math. Alright, so doing this way, it means we are finished our today's lesson. So we've covered the if-else, here, the now set, and then we've covered the we've used calculating average, and then we've applied to a data frame, and then we have used the case when, then we've used the data frame, the case when, to group the categorical variables like the age group, and you can group as well other categorical variables, and then we've used to calculate the median using the if-else. This one, the grouping, we're using the when, the case when method, and then we have another one, the switch. Okay, median we're using the if-else as well, but the switch operator, like the dividing the calculators and the like. Then we'll use this switch here, and then we have again the for loops, using loops here. So yeah, so there are many things that you can do. Alright, bye.